Let's look at the solution to the JAMB Chemistry 2023 examination questions. Question 1 says, Solvay process is used in the preparation of A. Sodium trioxocarbonate, B. Calcium trioxocarbonate, C. Sodium hydrogen trioxocarbonate, D. Hydrogen trioxocarbonate. Now for this question, the correct answer is A. Sodium trioxocarbonate. All right. You want to note that the term Solvay process is an industrial method used for the production of sodium carbonate, also called washing soda, using brine and limestone. All right. So in the Solvay process, sodium carbonate, also called washing soda, is being produced from brine, right? Brine spelled this way, from brine, that's this, and limestone. All right, so this is the concept of the Solvay process. Next up, question number 2 says electrolysis of molten sodium chloride. I think this should be in the electrolysis of molten sodium chloride. Z is D. You have A, B, C, and D. Now, this question is supposed to come with a diagram, okay, but the diagram is not here. But then, judging from previous years, all right, this question has been repeated, and the answer is usually A, all right. Z is usually the anode where chlorine ions are oxidized, all right. So take note of this. Now, what you should know about this question is that molten sodium chloride contains sodium ion, that's Na plus, and chlorine ion, that's Cl minus. Again, so oxidation happens at the anode, all right? And when the oxidation happens, what results is that chloride ions lose electrons. So for this particular question, the answer is A, that Z is the anode where chlorine ions are oxidized. That is the answer. So next up, question 3 says, the number of isomers of C5H12 is A, 4, B, 3, C, 2, D, 1. So what's the answer for this question? Now for this question number 3, you want to take note that C5H12 actually has 3 isomers. All right, it has 3 isomers. The first isomer there is your normal pentane. So you have N-pentane. That's your first isomer. The second isomer you have is called the isopentane. All right, it's called isopentane. And isopentane is simply methylbutane. All right, it's actually methylbutane. Here's the second isomer. Then the third isomer is neopentane. All right, neopentane. And neopentane is simply dimethylpropane. All right, so basically, these are the 3 isomers of C5H12. So for this question, the correct answer is B, 3. All right, question 4. Question 4 says the relative molecular mass of an alkyne with 6 carbon atoms is A, 78, B, 84, C, 82, D, 72. So what's the correct answer for this question? For question 4, they said an alkyne, and we know that for an alkyne, the general molecular formula for an alkyne is CnH2n minus 2. Now, when they said an alkyne with 6 carbons, for 6 carbons, it means that N is equal to 6. Let's put N as 6 into this equation. You have Cn, that's C6. H into 2N means 2 times 6. Then, of course, minus 2, this one here. If you solve this, this gives you C6 into H into 2 times 6 is 12. 12 minus 2 is 10. So you have C6H10. This is the alkyne with 6 carbon atoms. You're asked to find its molecular formula. For the molecular formula, let's start with carbon. Carbon has 6 atoms times its atomic mass, which is 12. So you have this plus for hydrogen, hydrogen has 10 atoms as seen, times the atomic mass of hydrogen is 1. Let's combine this. 6 times 12 is 72 plus 10 times 1 is 10. 72 plus 10 gives you 82. So hence, the molecular mass of this is 82 gram per mole. That's the molecular mass of this. So let's see which option that is. 82 is option C. So option C is the correct answer. All right, moving on. Let's look at question 5. Question 5 says, what mass of copper will be produced by the cathodic reduction of copper 2 ion when 1.60 amperes of current passes through a solution of copper tetraoxosulfate 6 for 1 hour? You're giving Faraday's constant here, 96,500. You're giving the atomic mass of copper as 64. You have your option A, 7.64 grams, B, 3.82 grams, C, 1.91 grams, and then D, 0.96 grams. Now, for this question, we're going to be using a particular formula, and I will do a very brief derivation of the formula. All right. So let's derive the formula for question 5. Now, for question 5, the first thing you want to recall is from Faraday's first law. For Faraday's first law, we know that the mass of a substance deposited is directly proportional to the quantity of electricity passed, that's Q. All right. And in science in general, if you have if you have your proportionality sign, all you have to do is replace it with equality sign and put your constant. So M, I'll replace this with equal to, the constant is Z, then bring in your Q. So I have this. So M is equal to Z times Q. Let's name parameters. M is the mass deposited. Let's take notes. Mass deposited. Z is the electrochemical equivalent. All right. Electrochemical equivalent. And Q is the quantity of electricity. All right. Quantity of electricity. All right, so you have this. Now with this, also recall that current is the rate at which charges flow, right? The rate of flow of electrical charges. So current I is equal to Q over T. From here, if you cross multiply, this is all over 1. Q times 1 gives you Q. So Q is equal to I times T gives you what there? IT. So I have this. If I put this, let's call this equation 1. And let's call this equation 2. If I put equation 2, let's put 2 into equation 1. That means in place of this Q here, I'll put what there? IT. So it means M is equal to ZIT. So have that the mass M is equal to Z times current times time. So we have this. All right. So at this point, we also want to note something from Faraday's second law. From Faraday's second law, we know that the equivalent mass is equal to capital M all over N, where M represents molar mass, that's M, capital M is molar mass, and N is the number of electrons exchanged. So number of electrons, E minus, that's N, all right? The number of electrons exchanged. And of course, we know that 1 Faraday, which is 96,500 as given, right, deposits 1 mole of electrons. This deposits 1 mole of, let me write this better, 1 mole of electron. So what does this mean? This means that the value of Z, which is called the electrochemical equivalent, Z, is actually given by the ratio of the equivalent mass all over F. That's Faraday's constant. So this is equal to equivalent mass, as we said earlier. Look at this, is equal to molar mass all over number of electrons. So it becomes molar mass all over number of electrons. This divided by F. So divide this by F, divided by F. Of course, if you're working on this, this is equivalent mass divided by F there. If you're working on this, we can simply change this to what there? Times. So this from here, Z will be equal to the molar mass all over number of electrons times 1 over F. And this will be equal to M times 1 is M all over NF. Now, I was looking for this. Let's now take this into this our formula here. So it means that the mass M is equal to Z, all right, which is this Z here. We got Z here as capital M molar mass all over N times F. That's, sorry, let me use small mass here. The mass M is equal to Z capital M all over number of electrons transferred times F. This is your Z. So Z then times I times T. So Z, this times current I times time T. All right, so this was the formula I was looking for. All right, this is the formula we use in solving this particular question. All right. Okay, so let's now put in values. Let's put in values. This is equal to the molar mass as given in the question there. They give you the molar mass of copper as 64. So that's 64 all over N. Now, if you look at the chart, they said copper Cu2 plus. That means number of electrons transferred is 2. All right, plus means it has lost electrons. And you can see 2 there, it means it lost 2 electrons. So N is 2 times F. They give us F as 96,500. This times the current. The current in the question was 1.6 amperes times the time. The time was given as 1 hour. And we know that 1 hour is equal to 60 times 60, converted to seconds, which is equal to 3,600 seconds. So time becomes 3,600 seconds. So we have this. All right, so let's get this done. So this is equal to, I'll multiply all numerators, 64 times 1.6 times 6,000, 3,600. 64 times 1.6 times 3,600. That gives you 368,640. 640 all over multiplied denominator 2 times 96,500. That's 193,000. From here, M is equal to, if you do your division, you have this as 368640 divided by 193,000. That's 1.91. 1.91. The mass is in kilograms, or it's in grams, please, right? The mass is in grams. So it's 1.91 grams. That is option C, 1.91 grams. So that's your correct answer. All right, next up, question number 6. Question 6 says, which of the following is used to power steam engines? All right. For this question, the correct answer is coal. All right. Steam engines are powered using coal. All right. For this question, you want to note that steam engines require heat. All right. And then coal is the traditional fuel used to supply the heat. So coal becomes the correct answer. Question number 7. 7 says the situation obtained when a perfect gas expands into a vacuum is, you have option A, you have option B, you have option C, and you have option D. Now, for this particular question here, you want to note that they gave you change in H here. You can see this. They give you change in H. You literally have change in H in all of the options. And change in H here, when you see change in H, what this represents is simply the change in enthalpy. All right, so change in H means change in enthalpy. That's the meaning of change in H, change in enthalpy. Also, you have change in S. All right, change in S simply means entropy increase, or perhaps change in entropy. Now, for this particular question, what's the correct answer? considering that a perfect gas expands into a vacuum. When a perfect gas expands into a vacuum, what happens? Now, two things happens. First, the change in H, that's the change in enthalpy, would be equal to 0. That's the first one there. And of course, T change in S, which is the disorderliness or entropy, will be positive because there will be disorderliness because the gas is literally expanding, right? So the entropy would increase. Now, why this is correct is because number one, change in H is equal to 0. And change in H is equal to 0 is because no work is being done. And when no work is being done for a gas, we'll have that the change in enthalpy is equal to 0. That's the first thing there. And number two, the change in H would increase. All right, it will increase. That means it will be greater than 0. It would increase because disorderliness increases. And since disorderliness increases, we can say entropy increases. So let's see which option matches this. So looking at the different options there, obviously option D is the correct answer. Change in H is 0, and the change in enthalpy is 0. No work is being done. And of course, the entropy will be positive as there will be disorderliness due to expansion of the gas. Okay, question 8 says, if the vapor density of an organic compound is 78, calculate its molecular formula. You have option A, option B, option C, and option D. So how do we solve this question? Now for question 8, you want to note that the molar mass or molecular formula for question 8, the molar mass is always equal to 2 times Vp, where Vp is the vapor density. And this is equal to 2 times, the vapor density is 78. And that's equal to 2 times 78. The value there is 156. So I have 156. So this is the molecular mass or the molar mass. Now, of course, in gram per mole, molar mass in gram per mole, all we have to do is, from these options, we'll pick out which of these will have the molecular mass as 156. Let's start with any one random. Let's start from D, or let's move from D to C and then B and A. From D, for D, you have C11, H24. All right. For carbon, we know that for carbon, the atomic mass is 12. 12 times 11, that's for carbon. Plus, for hydrogen, the atomic mass is 1. That becomes 1 times 24. All right, let's sum this up. So this becomes, open a bracket, 12 times 11, close the bracket, plus, open a new bracket, 1 times 24, close the bracket. The answer here is 156. So I have this as 156. This is 156. So hence the correct answer is C11H24. So D is the correct answer. This one here. All right, moving on. Question number 9. Question number 9. In the reaction between sodium hydroxide and sulfuric acid solutions, what volume of 0.25 molar sodium hydroxide would exactly neutralize 10 centimeter of 1.25 molar sulfuric acid? A. 5 cm cubed, B. 10 cm cubed, C. 20 cm cubed, D. 50 cm cubed. Now, to solve this question, this is a question on titration, right? And to solve, this is a question that involves the reaction between an acid and base. So let's get the complete equation of this reaction. They said the reaction between sodium hydroxide, so we're going to react sodium hydroxide, which is a base, and sulfuric acid. So we have acid and base. So question 9, we have acid H2SO4, sulfuric acid, combining with sodium hydroxide, NaOH. Now, we know that when an acid combines with a base, it forms salt and water. The salt formed here is sodium Na2O4, sodium tetraoxosulfate 6, plus water, that's H2O. This is your typical neutralization reaction. Looking at this, you see that the equation is not balanced. You have 2 moles of sodium here. I'll just add 2 here. So you have this. Also, looking at this, for hydrogen, you have 2 hydrogen here, and then 2 times 1 here, 2 hydrogen. In total, here you have 4 hydrogen atoms, right? Meanwhile, here you have just 2 hydrogen atoms. So I'm going to be adding 2 here. That makes it 4. Now, I think with this, everything is now balanced. All right, so we now have a balanced equation of the reaction. Let's take their coefficients. All right, let's take their coefficients or concentration. For here, we have 1. So I have 1 is to, here we have 2. That's the number here, 2. 2 is to, here we have 1. That is 1 is to, here we have 2. So from here, we can see that the number of moles of the acid, which is sodium, which is sulfuric acid, is actually equal to 1. And the number of the moles of the base needed, let's call this B, will be equal to what there? 2. So I have it as 2. So we have this. Again, recall that the number of moles N is equal to C times V, where C is concentration or molarity and V is volume. For acid, let's start with acid there. For acid, you have that N of acid, of course, is equal to C of acid times V of acid. And C of acid, okay, also for base, we'll come to that. For base, you have that N of base is equal to C of base times V of base. To solve this question, we'll need the ratio, all right? We need the ratio of the number of moles of acid all over number of moles of base. That's equal to, for acid, you have CaVa, all over for base, you have CbVb. All right. In the question again, let's pick out values. They said, what volume of 0.25 molar solution or molar sodium hydroxide? So what you have there, 0.5 molar, simply represents the concentration of sodium hydroxide, which is the base. So C of B, Cb, let's write it there. Cb is equal to 0.5. That's your value. 0.5 molar. That's what it meant. Okay. What again do you have here? They said would exactly neutralize 10 cm. This would be cm cube, right? 10 cm cube. That's talking about volume. 10 cm cube of 1.25 molar sulfuric acid. So for the acid there, the volume of the acid is 10. So volume of acid is equal to 10 cm cube. And then we have the concentration of the acid, which is in molar, would be 1.25 molar. So you have 1.25 molar. And they said, what volume of the base? So volume of the base is unknown. So Vb is equal to unknown. Okay, so let's put in values. N of A is 1. So you have 1 all over. NB, number of moles of the base, as you can see here, is 2 from the balance equation. So all over 2 is equal to, you have Ca. Ca is 1.25. Va is 10. So 1.25 times 10. 1.25 times 10. All divided by, next up you have Cb, that's concentration of base, which is 0.5. So 0.5 into Vb, which is what we asked to find. Let's cross multiply 1 times this. So that becomes 1 times 0.5 Vb is equal to 2 times this becomes 2 times 1.25 times 10. Now for this left hand side, 1 times 0.5 Vb gives you 0.5 volume of base is equal to 2 times 1.25 times 10. That gives you 25. So you have 25 here. To get Vb, divide here by 0.5, divide here by 0.5. This cancels this. The volume of the base is equal to 25 over 0.5. That's 50. So the volume of the base is 50, and we're using cm cube. So you have 50 cm cube. Let's see which option that is. That is option D, 50 cm cube. So that's your answer. Question 10 says, which of the following produces relatively few ions in a solution, right, or in solution? A, sodium hydroxide, B, calcium hydroxide, C, potassium hydroxide, D, aluminium hydroxide. Now, for this question, the correct answer is D, aluminium hydroxide. Okay, you want to know that aluminium hydroxide is sparingly soluble, so it produces very few ions because it does not always dissolve, right? So it's just slightly soluble, and hence it produces just few ions. So D is the correct answer. Question 11 says an element X forms the following compounds with chlorine. You have HCl4, HCl3, HCl2. This illustrates the A, law of multiple proportions, B, law of chemical proportions, C, law of simple proportions, D, law of conservation of mass. So which of these is the correct answer? Now, for this question here, the correct answer is A, the law of multiple proportions. Okay, you want to note that the law of multiple proportions states that whenever the same two elements form more than one compound, that the different masses of one element that combine with the same mass of the other elements are in the ratio of simple whole numbers. So you can see that the different masses of one element, which is chlorine, you can see the different masses of chlorine, chlorine 2, chlorine 3, chlorine 4, that combines with the same mass of the other element. So it's just X here, that's having just one atom. So it's just X and then X and then X. They said they combine with the same mass of other elements are in the ratio of simple whole numbers. You can see these are actually simple whole numbers, 2, 3, and 4. So it supports the law of multiple proportions. Let's look at question 12. Question 12, consider the following exothermic reaction. Two molecules of sodium dioxide combines with a molecule of oxygen gas to produce two molecules of sodium trioxide. If the temperature of the reaction is reduced from 800 degrees Celsius to 500 degrees Celsius and no other change takes place, then A, the reaction rate increases, B, the concentration of sodium trioxide decreases, C, the concentration of sodium trioxide increases, D, sodium dioxide gas becomes unreactive. Now, for question 12, the correct answer there is C, the concentration of sodium trioxide increases. Now, here's what to note. This is an exothermic reaction, right? And for an exothermic reaction, what happens is that number one, lower temperature favors the product. So looking at the equation of the reaction there, the product is this, which is the sodium trioxide. And since lowering the temperature for an exothermic reaction would favor the product, it means more of the product will be formed. And if more of the product is formed, it logically implies that the concentration of the product would increase. So hence, the concentration of sodium trioxide increases. That becomes the correct answer to this question. All right, question number 13. 13 says, at what temperature is the solubility of potassium trioxynitrate 5 equal to that of sodium trioxynitrate 5? At what temperature? A, 0 degrees Celsius, B, 30 degrees Celsius, C, 40 degrees Celsius, D, 45 degrees Celsius. For this question, the correct answer is C, 40 degrees Celsius. And we know this because there's something called the standard solubility curve. All right, there's a graph known as the standard solubility curve. And for that graph, which is the standard solubility curve that shows the curves for different compounds, right? You'd see that if you look at the curve there or that graph, you see that potassium trioxynitrate 5 and sodium trioxynitrate 5 both intersect at 40 degrees Celsius. So the correct answer there becomes 40 degrees Celsius according to the graph from the standard solubility course. All right. Okay, question number 14. 14 says the reaction between an organic acid and an alcohol in the presence of an acid catalyst is known as A. Saponification, B. Dehydration, C. Esterification, D. Hydrolysis. Now, for this question, if you look at this, it said organic acid. So we have acid plus, they said, plus alcohol. When you combine acid and an alcohol, what will be formed is simply something called an ester plus water. And this whole process is called esterification. So in essence, the correct answer there is C, esterification. That is your answer. All right, moving on. Question number 15. 15 says the knowledge of half-life can be used to A. Create an element, B. Detect an element, C. Split an element, D. Irradiate an element. Now, for this question, the correct answer there is B. Detect an element. All right. So you want to note that half-life, or the concept of half-life, helps to identify radioactive elements. So we can usually identify radioactive elements using the concept of half-life. And since we can identify radioactive elements, we can say we can also detect an element using the knowledge of half-life. So B is the correct answer. All right, next up, question number 16. 16 says, which of these alloys contains copper? A. Solder, B. Steel, C. Permalloy, D. Bronze. All right. You want to know the following. Now, for this question, the correct answer there is bronze. Okay. Bronze is an alloy of two elements there, which are copper and tin. All right. So bronze contains copper and tin. For solder here, solder contains lead and tin. Perhaps I should add this. Bronze is simply copper plus tin. That's Sn. That's tin. For solder, solder is simply lead, that's Pb, plus tin, that's Sn. And of course, to steel, when we talk about steel, steel here is a combination of iron and carbon. So steel is iron, Fe, plus carbon, that's C. So you have this, all right? So the one that contains copper as requested is bronze. So bronze is the correct answer. Next up, question number 17. 17 says, which of the following is discharged at the cathode during the electrolysis of brine using platinum electrode? A. Hydrogen ion, A. Hydrogen gas, B. Sodium, C. Chlorine gas, D. Hydroxide ion. So what's the correct answer here? Now, for this question here, the correct answer there is A. Hydrogen gas. All right. Now, at the cathode, what you have there, the reaction for number 17, the reaction at the cathode is simply you have water, all right? This plus two electrons. Of course, this is two to balance this up, all right? So what we produce, you have water dissociating to hydrogen gas, that's H2, plus two molecules of hydroxide, two molecules of OH ion, all right? So for this, what will be produced majorly is hydrogen gas. So that's the correct answer. So for 17A, hydrogen gas is the correct answer. Question 18. 18 says, calculate the quantity of electricity required to deposit 28.64 gram copper from its salt solution. You're given the atomic mass of copper, you're given Faraday's constant. You have your option A, option B, option C, and option D. All right. So which of them is the correct answer? For question 18, the equation of the reaction is this. All right. You have copper ion losing two electrons to give you copper here. Now, looking at this, you can see that the number of electrons that is discharged, which is N, will be equal to 2. All right. 2 electrons will be given out, or from here. All right, 2 electrons will be given out. And the formula for the quantity of electricity deposited, Q, is given by M, the mass, times n, the number of electrons discharged, times F, Faraday's constant, all over m, the molecular mass or atomic mass, as the case may be. And this is equal to the mass as given in the question is 28.64, 28.64, that's the mass, times n, the number of electrons discharged is 2, times Faraday's constant 96,500, all over capital M, right? Capital M there represents the atomic mass of copper, which is 64, right? If you punch all of this, Q will be equal to, let's get numerator. So I'll just get my calculator real quick. Let me get my calculator real quick. Okay, so we have 28.64 times 2 times 96,500, and that gives you 5527,520. This divided by 64. So let's divide this by 64. So this divided by 64, you have your answer there as 86,367.5. This would be in coulombs. All right, so let's see if you have this option there. Yep, that is option D, and that's your correct answer. Let's look at question number 19. 19 says, which of the following metals cannot replace hydrogen from water or steam? A, sodium, B, magnesium, C, iron, D, calcium. For this question, the correct answer is C, iron. All right. You want to take note that sodium and calcium, that's A and D, can react with cold water. All right. So sodium and calcium reacts with cold water. Also for option B, magnesium reacts with hot water or steam. So why sodium and calcium will react with cold water, magnesium would react with hot water or steam. Meanwhile, for iron reacts only with steam and not water easily. So for the options provided here, the least reactive is iron. So when they say which of the following metals cannot replace hydrogen from water or steam, it's usually iron. All right, so that's your correct answer. Finally, question 20. 20 says the elements in the periodic table are listed in order of increasing: A, relative atomic number, B, atomic mass, C, relative isotopic mass, D, nuclear charge. Now for this question here, the correct answer there is D, nuclear charge. All right. So note that the nuclear charge is simply equal to the atomic number. All right. And it increases across the periodic table. And when it comes to periodic table, elements are arranged according to their atomic number, which is what we said is the same thing as the nuclear charge. And just as the nuclear charge increases across the periodic table, that is how elements are being arranged in the periodic table. So the correct answer there is D, nuclear charge. Question 21 says, calculate the pH of 0.05 mole per dm cube H2SO4, that's sulfuric acid. A, 1.30, B, 1.12, C, 1.00, D, 0.30. Okay, so how do we solve this question? Now for question number 21, the first we want to do here is to recall the formula of pH. Recall the pH formula. And the pH formula is given by pH is equal to negative log of the concentration of hydrogen ion, right? Negative log of the concentration of hydrogen ion. And if you write out the equation of the reaction, right, we'll have that H2SO4, that's tetraoxosulfate 6 acid. This will be broken down into two ions. The first one is the hydrogen ion balance, that's this. plus we have SO4 2 minus ion. That's tetraoxosulfate 6 ion. Now, if you consider the hydrogen ion here, right, if you look at this, we have 2 of the hydrogen ion, 2 moles of the hydrogen ion. And that means that becomes 2 times. If you look at the question here, they said 0.05 mole per dm cube of this particular H2SO4 here. So that means for this, it becomes 2 times the hydrogen ion. We'll use this value that's given here, 0.05. So that becomes 0.05. So if you do this, 2 times 0.05, that will be equal to 0.1. We have this. All right. So with this, let's use the formula for pH. So we'll have that the pH is equal to negative log of the concentration of the hydrogen ion. Since you have 2 molecules of the hydrogen ion, we had to multiply it by 2, which gave us 0.1. So in essence, the value we use for the concentration of hydrogen ion would be this value here. That's negative log 0.1. All right. So let's punch this. I'll get my calculator and I'll punch negative log 0.1. And if you punch that, your answer gives you 1. So the answer to this question is 1. Let's see which option supports that. That's option C. The correct answer is 1. So that's your answer. Next up, let's look at question number 22. All right. For 22, the question here says the basicity of propanoic acid is A 4, B 3, C 1, D 2. All right. Now, for this question here, you want to know that propanoic acid is actually given by this. All right. For propanoic acid, your formula is simply CH3, CH2, COOH. All right. So this is the formula for propanoic acid. And you're asked to find the basicity. Now, you want to note that the basicity of an acid refers to the number of hydrogen atoms that is replaceable by a base. So when we have this, which of these are hydrogen atom, or how many hydrogen atoms here can be replaced by a base? For this question here, the only hydrogen atom that can be replaced by a base is this one here, all right, which is the one attached to the radical, that's COOH here. All right, so note that propanoic acid has just one replaceable hydrogen ion, and that's the hydrogen ion in this one here, in the COOH, this one here. All right, so the answer here is 1. So 22, the answer there is 1. That's your correct answer. Question 23. 23 says, in which of the following molecules is hydrogen bond prominent? A, you have silicon tetrahydride. B, you have hydrogen fluoride. C, you have sodium hydride. D, you have CH4, which is methane. So for 23 here, what is the correct answer? For this question, the correct answer is B, that's hydrogen fluoride. You want to note that the strongest hydrogen bond is the hydrogen bond in hydrogen fluoride. This is because the strength of hydrogen bond decreases down the group of the halogens. The strongest hydrogen bond is in the hydrogen fluoride. So the correct answer is B, hydrogen fluoride. Okay. Again, you want to note that hydrogen bond occurs when hydrogen is bonded with either fluorine, oxygen, or nitrogen. So the option that matches any of this is fluorine. So fluorine, B, is hydrogen fluoride, is your correct answer. Next up, question number 24. 24 says the periodic classification of elements is an arrangement of the elements in order of their A, atomic weights, B, isotopic weights, C, molecular weights, D, atomic weights. For question number 24, the correct answer is D, which is atomic weight. So atomic weight D is the correct answer. You want to note that elements in the periodic table are arranged according to the atomic number. By atomic number, we mean the number of protons, okay? And of course, the modern periodic table uses atomic number in order to arrange elements and not necessarily atomic mass or mass number. So the correct answer is D, atomic numbers. That's the correct answer. Question 25. 25 says, in the upper atmosphere, the ultraviolet light breaks off a free chlorine atom from chlorofluorocarbon molecule. The effect of this is that the free chlorine atom will A, be very reactive and will attack ozone. B, be non-reactive and will not attack ozone. C, not change the level of ozone in the atmosphere. D, increase the level of ozone in the atmosphere. For question 25, the correct answer is A. It will be very reactive and will attack ozone. All right. For this question, you want to note that chlorofluorocarbons, also called CFCs, all right, that's the short form. Chlorofluorocarbons, they have a timeline in the atmosphere of about 20 to 100 years. And consequently, one free chlorine atom from a CFC, that's chlorofluorocarbon molecule, can do a lot of damage, destroying the ozone molecule for a long time. So note that the CFC, that's chlorofluorocarbon molecules, can do a lot of damage, destroying the ozone molecule for a long time. So the correct answer there is A. It will be very reactive and it will attack ozone. Now, when it attacks ozone, what happens is that it will now thin the ozone layer, right? It attacks and destroys ozone molecules, thereby thinning the ozone layer. Next up, question number 26. For 26, the question there is, the end products of burning a candle in the atmosphere are water and A, carbon 2 oxide, B, sulfur 4 oxide, C, carbon 4 oxide, D, sulfur 6 oxide. For question number 26, the correct answer there is C, which is carbon 4 oxide. For 26, you want to note that when we ignite a candle, the hydrocarbon reacts with oxygen in excess to produce carbon dioxide and water. The burning sets an air current which gives dome shape to candle flames. And that's why you have candle flames. If you have a candle here, right, if you lit a candle like this, you have the shape being like this. All right, it gives this dome shape to candle flames, and it helps to get complete combustion at the bottom and the outer surface of the flame. So carbon dioxide is produced. That is your correct answer. You also want to note that candle wax is a hydrocarbon, and complete combustion will give you carbon dioxide. So carbon dioxide is the answer. Next up, question number 27. 27 says, which of the following is used for preserving food? A, pentanoic acid, B, butanoic acid, C, benzoic acid, D, methanoic acid. Now, for question number 27, the correct answer is C, benzoic acid. All right. So take note that benzoic acid is a common food preservative. All right. So benzoic acid is your correct answer. Next up, question 28. 28 says, when large hydrocarbon molecules are heated at high temperature in the presence of a catalyst to give smaller molecules, the process is known as A, disintegration, B, polymerization, C, cracking, D, degradation. For this question there, the correct answer is C, cracking. All right. Cracking is simply the use of heat and catalyst to break down larger molecules into smaller molecules. Okay. The concept of cracking involves the breakdown of a large alkane into smaller, more useful alkane. So that's the concept. So it's cracking. Cracking is your correct answer. Question 29. It says, in electrovalency, the oxidation number of the participating metal is always A, decreasing, B, increasing, C, constant, D, neutral. For this question 29, the correct answer there is B, increasing. So please take note that during electrovalency, metal loses electrons. All right. So since metal loses electrons, their oxidation number increases. And since the oxidation number increases, we can say for this particular question there, the correct answer is B, increasing. So the oxidation number of the participating metal in electrovalency, it would increase because the metal loses electrons. That is your correct answer. Finally, question 30. 30 says the collision theory explains reaction rates in terms of A. Size of the product, B. Frequency of collision of the reactants, C. Size of the reactant, D. Frequency of collision of the products. So for this question here, what is the correct answer? For question 30, the correct answer there is B. The frequency of collision of the reactant. And this is true because when we talk about the concept of collision theory is used to predict the rates of chemical reactions, particularly for gases. All right. The collision theory is based on the assumption that for a reaction to occur, it is necessary for the reaction species, that's either atoms or molecules, to come together to collide with one another. So the reactants must come together to collide with themselves before a product can be formed. Hence the reaction rates in terms of hence the collision theory explains reaction rates in terms of the frequency of collision of the reactants. So the more the reactants collide, the more or the faster products will be formed. That is the concept of the collision theory. Question 31 says, when heat is absorbed during a chemical reaction, the reaction is said to be A. Thermodynamic, B. Exothermic, C. Isothermal, D. Endothermic. For question 31, the correct answer is D. Endothermic. All right. Now you want to note that there are two types of reaction in reference to heat change. They are number one, endothermic, number two, exothermic. So you have this one here, endothermic as number one. You have number two here as exothermic. All right. Endothermic reactions are reactions that involve the absorption of heat, while exothermic reaction involve giving out heat to the surrounding. So for this case, it is said when heat is absorbed, that becomes endothermic. So endothermic is the correct answer. Question 32. 32 says the hydrogen ion concentration of a sample of orange juice is 2.0 times 10 to the power minus 11 mole per dm cube. What is the pOH? All right. You're giving log of 10 to the power 2 as equal to 0.3010. A is 3.3, B is 13.00, C is 10.70, D is 11.30. So which of these is the correct answer? Now for 32, you want to know that the formula for pOH, let me write this better. pOH, the formula is given by negative log of the concentration of the hydroxide ion. That's this. All right, so you have this. And if you look at the question there, they gave you the formula for, or they gave you the value for the concentration of hydroxide ion. They give you that as 2.0 times 10 to the power minus 11. So this value becomes 2.0 times 10 to the power minus 11. From here, we can have that pOH is equal to minus log. This value is 2 times 10 to the power minus 11 or 2.0, same thing. So I'll just get my calculator and punch this. If you get your calculator and you punch this value here, negative log in bracket 2 times 10 to the power minus 11, your answer gives you 10.7, right? Or 10.70. That's your answer. So looking at this, the correct option there is C, 10.70. That's your answer. Next up, question 33. Which of the compound is composed of aluminium, silicon, oxygen, and hydrogen? A. Epsom salt, B. Limestone, C. Clay, D. Urea. For question 33, the correct answer there is C, which is clay. All right. You want to know that clay consists of aluminium, silicon, oxygen, and hydrogen. So next up, question 34. 34 says zinc oxide is A. Basic oxide, B. Acidic oxide, C. Amphoteric oxide, D. Neutral oxide. Now for this question here, the correct answer is C. amphoteric oxide. You want to note that zinc oxide is an amphoteric oxide. And by amphoteric oxide, we mean that zinc oxide acts or reacts with both acids and bases. All right. When we talk about amphoteric oxide, these are oxides which act both as an acid or as a base under different conditions. That means they have both acidic and basic properties, which means they can turn red litmus paper blue, and in some instances, they can turn blue litmus paper red. So zinc oxide is amphoteric. It acts as an acid and also as a base. C is the correct option. Next up, question 35. 35 says a diminishing ozone layer with an increase in ultraviolet radiation is a result of the presence of A. Chlorofluorocarbons, B. Hydrocarbons, C. Oxides of sulfur, D. Oxides of carbon. For question number 35, the correct answer is A. All right, chlorofluorocarbons. So these are known as CFCs. All right, CFCs are chlorofluorocarbons, and what they do is that they release chlorine radical, and this chlorine radical destroys or lowers the layer of the ozone. So when you have that the ozone layer is being diminished or reduced, it is as a result of chlorine radicals that is being released by the CFCs, which is the chlorofluorocarbons. So the correct answer for this question is chlorofluorocarbons. Let's look at question number 36. Question 36 says, calculate the percentage composition of oxygen in calcium trioxocarbonate 4. Ca, they gave you the atomic mass of calcium as 40, for carbon as 12, for oxygen as 16. You have option A as 16, option B as 48, option C as 40, and option D as 12. So let's get the percentage composition of oxygen in this compound. Now, the given compound here is CaCO3. Let's get the molecular mass. For carbon, the atomic mass of carbon is 40 plus, for calcium, the atomic mass of calcium is 40 plus, for carbon, the atomic mass of carbon is 12 plus, for oxygen, the atomic mass of oxygen is 16. So it becomes 16 times the number of atoms, which is what there? 3. If you combine this gives you 40 plus 12 plus 48. And this gives you a total of 100. All right. So for calcium trioxocarbonate, that's CaCO3, the molecular mass is 100. Now, if you want to get the percentage composition, so percentage composition, this of oxygen, that will be equal to the mass of oxygen times n, where n is the number of atoms present there, all over molar mass of the compound, which is molar mass of the compound CaCO3 times 100%. So times 100%. This is equal to mass of oxygen, as we can see here, is 16. All right, 16 times number of atoms. In this compound, you have 3 atoms of oxygen, so times 3, all over molar mass of the compound is 100 times, of course, 100%. Right, as we said earlier. From here, this will be equal to 16 times 3 gives you 48. That's 48 all over 100 times 100%. This cancels this. This is equal to 48%. So the correct answer to this question is 48%. For 36, the answer is B, 48%. All right, moving on. Question 37. 37 says the oxidation state of chlorine in potassium chlorate is A plus 1, B plus 2, C plus 3, D plus 5. All right, what is the oxidation state? Now for 37 there, the compound mentioned here is potassium chlorate. And potassium chlorate is actually KClO3. All right, this is potassium chlorate. You're asked to find the oxidation state of chlorine. For potassium, we know that the oxidation number is +1, so 1 or +1, plus chlorine is unknown, we'll call it X, plus for oxygen, the oxidation number is -2 times number of atoms there, 3. We'll equate this to 0 because there's no charge here, there's no plus, there's no minus, so we equate it to 0. It's a neutral compound. This becomes 1 plus, this is X, plus -2 times 3 is -6. It's equal to 0. I have 1 plus X, plus minus is -6 equal to 0. I have here 1 minus 6 gives you -5. So X minus 5 is equal to 0. Let's get the value of X. So X is equal to, move -5 over here becomes +5. So the value of X there, or the oxidation number, is +5. And that is option D, +5. That's your correct answer. 38. A particle that contains 9 protons, 10 neutrons, and 9 electrons is A, positive ion, B, neutral atom of a metal, C, neutral atom of a non-metal, D, negative ion. Now, if you look at this, they said number of protons, P, is equal to 9, number of neutrons, N, is equal to 10, and number of electrons, E, is equal to 9. For a neutral atom, the number of protons will be equal to number of electrons. And you can see that proton is 9, electron is 9. So first things first, we know that it's a neutral atom. In the question, they said, is it a neutral atom of a metal or neutral atom of a non-metal? Now, how do we know that? We know that the atomic number is equal to the number of protons. And for this question here, the number of protons is 9. So for this question there, the atomic number is actually 9. So all we have to do is to check which element has its atomic number as 9. And as we know, the element with atomic number 9 is fluorine. And of course, fluorine is a non-metal. So in essence, this is a neutral atom of a non-metal. The correct answer becomes C, the neutral atom of fluorine, a non-metal. That's the correct answer. Question 39. The general formula of the arcanine is, all right, what's the general formula of the arcanine? You have option A, option B, option C, and option D. The correct answer here is B. This is under organic chemistry. Okay, you want to know that the arcanines are also called ketones. Right? Alkanones are also called ketones. And ketones have a carbonyl group between two alkyl group. The carbonyl group between two alkyl group. The structure is something like this for the ketone. The structure is something like this. Let's say R1, single bonded to carbon, double bonded to oxygen, and then the second one, the R2. All right. But sometimes you can combine this and this to give you RC double bonded upwards to O and then R. So if you write this in is condensed form, you have R2, that's this and this and this one here. You have C and then O. So that's how we got the R2CO. So that's it. Next up, or finally, question number 40. For question number 40, it says an organic compound contains 70% carbon, 12% hydrogen, and 18% oxygen by mass. Calculate the formula. All right, so you're asked to find the empirical formula for the compound here. Let's do this question. All right, so let's see what they said. They said carbon there. Carbon has, it says it contains carbon, hydrogen, and oxygen. For carbon, the value there is 70%. For hydrogen, it is 12%. For oxygen, it is 18%. Now, to get empirical formula, the first thing we have to do is to divide by the atomic mass. Let's divide both sides by atomic mass. If we do that, that becomes 70. For this one, it becomes 70 all over 12. This becomes 12 all over. For hydrogen, the atomic mass is 1, oxygen is 18, the atomic mass for oxygen there is 16. All right, so let's do this division here. If you do 70 over 12, this one here, your answer becomes 5.83. 5.83. 12 over 1. If you do this, your answer gives you 12. So I have this as 12. And then 18 over 16. If you do this, your value gives you 1.125. So first step, divide by atomic mass. The next step is to divide by smallest number. Let's divide by smallest number. The smallest number here is this one here. So that becomes 5.83 divided by smallest number 1.125. Then you have 12 divided by smallest number 1.125. Then you have this one here, which is 1.125. 1.125 divided by itself being the smallest number 1.125. All right. So if you do this, what do you have here? Divide this one here. You have your answer approximately as 5. Divide this, you have your answer approximately as 11. All right. Divide this one here, you have your answer as 1. So in essence, my answer should be C5, H11, and then O1 or just O. So this should be my answer. So let's see if any option rhymes here. C5, H11, O. Nope, there's no option here. But the correct answer should have been C5, H11, and then O. But in exam scenario, so this should have been the correct answer. Now, what we see here is actually the empirical formula. If you compare this with the answers there, you can see that the D has C10H12O2, which is simply multiplying this by 2. If you multiply this by 2, it becomes C 5 times 2 is 10, H 11 times 2 is 22, and then O 1 times 2 is O2. So I will go with this option. So perhaps this is the molecular formula. All right. So what we got initially, C5H11O2, is the empirical formula. But they say we should calculate the formula. They did not mention if it was empirical formula or molecular formula. But since we have something in this same concept, I'll go with D and I'll call it the molecular formula. Question 41 says, which of the following is used in the manufacture of petrol additive? A. Bromine, B. Iodine, C. Chlorine, D. Fluorine. For this question, the correct answer is C. Chlorine. Okay. Note that chlorine is used in the production of tetraethyl lead substitutes and fuel additives. All right. So it is used in the production of tetraethyl lead substances or substitutes and fuel additives. So the correct answer there is C, chlorine. All right, next question there. Question number 42. 42 says, a sample of hard water contains some calcium sulfate and calcium hydrogen carbonate. The total hardness may therefore be removed by A. Boiling the water, B. Adding excess calcium hydroxide, C. Adding a calculated amount of calcium hydroxide, D. Adding sodium carbonate. For question 42, the correct answer there is D. All right, adding sodium carbonate. You want to take note that sodium carbonate removes calcium ion, that's Ca2 plus, and magnesium ion, that's Mg2 plus. All right, and these two ions are responsible for the hardness of water. And with the help of sodium carbonate, you can remove these two ions. So hence, a sample of hard water that contains both calcium sulfate and calcium hydrogen carbonate, the total hardness may be removed by addition of sodium carbonate. So D becomes the correct option. Next up, question 43. Question 43 here says 2 moles of potassium chlorate using manganese 6 oxide, that's this, as your catalyst would produce 2 moles of potassium chloride plus 3 moles of oxygen. They said the importance of the catalyst in the reaction above, that's this one here, is that A, heating may not be required before the reaction takes place. B, the reaction is controllable even at high temperature. C, the reaction produces large quantity of oxygen. D, the reaction takes place more rapidly at lower temperature. For this particular question, the correct answer is D, that the reaction takes place more rapidly at lower temperature. You want to note that what you have there, this is manganese 6 oxide, is a catalyst. And they said the importance of the catalyst. The function of a catalyst in a chemical reaction is to lower the activation energy. And when the activation energy is being lowered, the rate at which it occurs is now faster. So hence, the function of a catalyst in any reaction is to increase the rate of a chemical reaction. So this says the reaction takes place more rapidly or faster at a lower temperature. And that is the correct answer. The simple idea for this question is that a catalyst helps to speed up the rate of a chemical reaction. And D is what matches that concept. So D is your correct answer. Question number 44. 44 says an ore of tin is A, hematite, B, magnetite, C, bauxite, D, cassiterite. For 44, you want to note that the ore of tin is actually D, cassiterite. All right. Cassiterite is actually SNO2. That's it. Okay. And this is the main tin ore. So the correct answer is cassiterite. Question 45. The solubility of lead 2 trioxynitrate 5 at 30 degrees Celsius, that's this, is A, 70 gram per 100 gram of water, B, 80 gram per 100 gram of water, C, 80 gram per dm cube, D, 90 gram per 100 gram of water. The correct option there is B, 80 gram per 100 gram of water. What you have here is the standard solubility data value used by JAMB. All right. So what you have here is actually a standard. Okay. So just note that what they use is 80 gram per 100 gram of water. It's a standard. It's a constant that is being used especially for JAMB syllables. So B is the correct answer. Next up, question number 46. Question 46. 3 molecules of hydrogen gas plus 1 molecule of nitrogen gives you 2 moles of ammonia. And you have that H is given as negative. All right. They said in the reaction above, that's this reaction here, lowering the temperature will A, have no effect on the equilibrium position, B, increase the rate of both the forward and reverse reactions equally, C, favor the forward reaction, D, favor the reverse reaction. So what's the correct answer to this question? For this question here, 46, this is called the Haber process. All right. It's a popular equation or process known as the Haber process. Okay. And for Haber process, the reaction is usually exothermic. All right. That means heat is lost to the surrounding. And that's why you have, this is supposed to be the change in H as being negative because heat is lost to the surrounding. Now, note that for the Haber process, lowering the temperature forwards products formation. All right. So if you look at the options there, the correct answer will be C, favors the forward reaction. Because in the forward reaction, if you look at forward reaction, what happens is that hydrogen combines with nitrogen to give you ammonia. All right. And since lowering the temperature for the Haber process favors products formation, we can say it favors the forward reaction because it is in the forward reaction that the product is being formed. That's it. All right. Next up, question number 47. Question 47 says, mixing 1 part of slacked lime and 3 parts of sand with water will produce A. Plaster of Paris, B. Cement, C. White paint, D. Mortar. For this question there, 47, the correct answer there is D. Mortar. All right. You want to note that slaked lime, slaked. Question 47 says, mixing 1 part of slaked lime and 3 parts of sand with water will produce A. Plaster of Paris, B. Cement, C. White paint, D. Mortar. Which of these is the correct answer? For this question, the correct answer is D. Mortar. All right. You want to know that slaked lime plus sand plus water, when all of these are combined, it will give you mortar. All right. What you have there is mortar. All right. So that's what will be formed. All right. Now, now you want to know that cement looks like a possible option, but then cement is manufactured and not mixed directly. All right. All right, the same thing could have worked for cement, but then cement is being manufactured and not mixed directly. In this question 47, they said when you mix 1 part of this, all right, the most correct answer would be, or the most correct option would be mortar. That's the most correct option and not cement. Okay, question 48. 48 says the ability to form complex and colored ions are characteristics of transition metals resulting from the number of electrons in their A. P orbital, B. S orbital, C. D orbital, D. F orbital. For question 48, you want to note that the cause of colored complex ion in transition metal is due to their partially filled d orbitals. All right. So for this question here, the correct answer is C. All right. Transition metals have partially filled d orbitals, causing color and complex formation. Question 49. An example of an endothermic reaction is the dissolution of A. Sodium hydroxide in water, B. Ammonium chloride in water, C. Copper tetraoxosulfate 6 in water, D. Calcium hydroxide in water. For 49, the correct answer there is B, which is ammonium chloride in water, right? You want to note that ammonium chloride absorbs heat when dissolving, which now creates a cooling effect. All right. So hence is an endothermic reaction. So B is the correct answer. Finally, question 50. What is the oxidation number of sulfur in FeSO4, which is ion 2 tetraoxosulfate 6? A minus 4, B minus 2, C plus 4, D plus 6. All right. So when you have FeSO4, all right, let's get the oxidation number of sulfur here. And how do we do that? The first thing you want to notice that for iron, in this question, the oxidation number of iron here is plus 2. All right. Now, iron usually has 2 oxidation numbers, plus 2 and plus 3. So how do we know that it's plus 2 for this question? Well, that's simple, because if you separate the ions Fe and then SO4, for SO4 is usually 2 minus. That means tetraoxosulfate usually has a 2 minus, and Fe has to be 2 plus. So that when they exchange, this one comes this way and this one goes this way. So you have Fe, this one comes here, so it becomes 2, then SO4 like this. This part 2 goes here, so it becomes 2. 2 cancels 2. You're left with FeSO4, which is what you have there as FeSO4. If this was ion 3, what you would have had would be Fe3 plus SO4 2 minus. This one goes here and this one goes here. So you'll be having Fe2 and then SO4 3. At this point, this and this cannot cancel since they're not the same thing. So this becomes ion 3 ion. Meanwhile, when you have this, you know that it's ion 2 ion. All right, so for ion, this one here, the charge is +2. Plus for sulfur, we want to look for it, so we don't know, we'll call it X. Plus for oxygen, we know that the charge on oxygen is -2 times the number of atoms, 4. You equate this to what? 0. From here, you have 2 plus X plus -2 times 4 is -8, equated to 0. From here, this becomes 2 plus x plus -8 is -8 is equal to 0. From here, you have 2 minus 8 is -6 plus x is equal to 0. From here, x is equal to +6. So the correct answer for this question is +6. So let's see which option matches that. So the correct option there is D, +6. So that is your correct answer. All right, guys. So with this, we've completed all of the questions in the JAMB Chemistry 2022 examination questions. All right. If you enjoyed this video, don't forget to hit the like button, leave a comment. Don't forget to follow us for revision on JAMB Physics, JAMB Chemistry, JAMB Mathematics, and JAMB Biology past questions. See you in our next class. Okay, guys, so please take note that we have a JAMB WhatsApp group for JAMB Bites. All right. So if you're writing JAMB, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites, or you can get the full JAMB course on our website. Simply visit www.jonahemmanuel.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right, for the comments, I gave you a task, question number 11. Solve it, leave your answer in the comment section, and I'll tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon, and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.